The monitoring wells have been installed in order to understand the extent of trichloroethylene, or TCE, in groundwater. There are a number of wells that are screened at different elevations or depths within the subsurface because it's a very thick aquifer. It's a glacial aquifer. And we find that the TCE occurs at different depths depending on where you are. So part of the challenges of monitoring and tracking the movement of this plume is being able to isolate and target where the TCE actually occurs, and also being able to document where it doesn't occur. That's also a very important part of what we do. The groundwater plume is quite complicated because of the thickness of the saturated zone and the old glacial geology. There are some clays down at depth. There's thick sands and thin sands. There's silts. And so one of the complexities of the site is not only understanding where it is when I look at a map, but also where it is vertically. So we prepare cross sections that are almost like you're taking a bulldozer and slicing the earth across. This is what it would look like if we could do that. And that helps us to better understand not only the lateral extent of the plume, but where it is below the water table. Is it 50 feet below the water table? Is it 80 feet? And that turns out to be very important when it comes to understanding whether or not a residential well might be impacted by this plume. A few things to understand about TCE in terms of its behavior in the environment. TCE is relative to water, it's a dense liquid. It doesn't readily dissolve in water. And so, unlike gasoline, which you might spill, and we've all seen sheens develop on the top of the water, and it's lighter than that water and it floats on the water, TCE will actually stay together, not spread out as much as gasoline will, and it'll move vertically down through that groundwater until it pancakes out on, say, a clay or something that doesn't allow it to freely move vertically. And as it moves, as TCE moves through the ground, whether it's saturated or not, some of that TCE gets stuck in the little spaces, the pores between grains, and it may stay there. Whereas, so you may lose 100 gallons on the ground, but by the time it gets to the water table, you won't have 100 gallons of TCE. Some of it will have been left behind and spread in the soil column. So in 2016, we measured groundwater concentrations along the former property boundary of the site, so where the manufacturing building was. And the reason we did that was because the manufacturing building has now been torn down, and as a consequence, there's a greater likelihood that rainwater can infiltrate into the soil. And the concern is that with more infiltration, now that that building isn't there, there's a potential that rainwater infiltrating through the ground will flush some of that TCE into groundwater. And in 2016, we did see the groundwater concentrations increase at the wells at the property boundary. And so in 2017, we will be doing additional investigations to look at what the conditions are like under that building. Now that it's not in active use, the DEQ has an opportunity to really explore that more. We'll be looking at the soil gas, so vapors that may be present in the soils under the building, and that could also come from the groundwater. So that's an important thing for us to consider in terms of being able to redevelop that property. Because ideally at some point it would be, I think, to the community's benefit to put that property back into some sort of reuse, beneficial use.